Welcome to Physics with Umoru. You can connect with us on Facebook, YouTube, and TikTok at Physics with Umoru. Please don't forget to comment, like, and subscribe to our YouTube channel and also our TikTok live lessons. Please, you can connect with us at Physics with Umoru. We have our number, our WhatsApp number on the screen. Last time we looked at circular motion as we are trying to discuss the simple harmonic motion. So today we are going to be looking at simple harmonic motion. When can we say a body is exhibiting a simple harmonic motion? A body is said to undergo simple harmonic motion when, number one, its acceleration is directed towards a fixed point. When the acceleration of the body is directed towards what we call the equilibrium point or a fixed point. And number two, when its acceleration is directly proportional to its displacement from the equilibrium or the fixed point. A body is said to undergo simple harmonic motion when its acceleration is directed towards a fixed point and directly proportional to its displacement from the point. So when this happens, the motion of that body can be termed simple harmonic. Motions that are simple harmonic must be periodic. It must be a kind of motion that repeats itself. For example, circular motion or the vibratory or oscillatory motion, just like we have here. The circular motion, for a motion to be simple harmonic, the motion must be a periodic motion, a motion that repeats itself at a given time. Okay, so we are going to be looking at the terms used in simple harmonic motion. Terms used in simple harmonic motion. We have number one, the period. The period, and the period is represented by a letter T, capital T, the uppercase letter T. The period of a body performing or exhibiting simple harmonic motion is defined as the time taken by the body to complete a cycle. That is the total time taken by the body to make one full cycle for the body to move away from the fixed point and return to the fixed point. And the formula, this is given by the time divided by the number of cycles. So if we can divide the total time taken by a body to oscillate or for the body to move from a fixed point, the total time, if we divide it by the total number of cycles made by the body, we are calculating the period, where the n here is the number of the oscillation on the number of the cycles completed, because it is possible that the body will make more than a cycle. So to find the period, we divide the total time taken by that body to complete this number of cycles. We divide it by the number of the cycle, and then we'll have the period. And the next is the frequency. How frequent the body oscillates, how frequent the body moves. Frequency, this is the number of cycles completed per unit time. The frequency of a body performing simple harmonic motion is the number of cycles completed by the body per unit time. So if we use F to represent the frequency is equal to N over T. Remember that this lowercase letter T is different from the uppercase, from the capital letter T, which is the period. This is the time taken for this number of cycle, but capital T is the time taken just for a cycle, time taken by the body to complete one cycle. So frequency is the number of cycles all over time, and period is time all over number of cycles. So with this, we can have it that frequency is the reciprocal of period. The frequency is the inverse of period, that is 1 over period. Since the period is t over n and frequency is n over t. Therefore, we can say that frequency is 1 all over time. Or we can also look at this way. If the number of cycle is 1, it therefore means that the time taken to complete one cycle is period. So if n is equal to 1, it therefore means that t is going to be capital T. That is, that the time becomes period when the number of cycle is 1. So with this, we can have the relationship connecting the frequency and the period as this. Therefore, we can also say that the period is 1 all over frequency if we make t the subject of the formula from here. The third one is the angular velocity. We are discussing the terms used in simple harmonic motion. The angular velocity, omega. This is the letter omega we use to represent the angular velocity. The angular velocity is defined as the angle turned through per unit time. That is the angular distance covered by this body per unit time. Remember that velocity or the speed. The velocity is defined as the linear velocity defined as the displacement per unit time. That is the displacement covered or the displacement of a body per unit time. So if the displacement or the distance covered by this body towards a given direction is in terms of an angle, the radial displacement, that velocity is what we call the angular velocity. So the angular velocity is defined as the angular displacement turned through per unit time, or the angular displacement covered by a body performing simple harmonic motion per unit time. So we have the formula replacing the displacement with angle. So we now have it that the angular velocity is theta all over time. And if we are to consider for one cycle, it therefore means that the angle turned through for one cycle, theta is meant to be 360 degrees for one cycle. For one cycle, the angle turned through for one cycle is 360 in degrees, but 2 pi in radians. It's 360 in degrees, but 2 pi in radians. So, and the time taken for one cycle, as we discussed before, the time taken for one cycle is referred to as period. So for one cycle, theta becomes 2 pi, and the time becomes period for one cycle. Theta becomes 2 pi or 360 degrees, but the unit of angular velocity is in radians per second. So because of this, we make use of radians instead of degrees. So therefore, we have it that the angular velocity is equal to 2 pi all over period. So take note of this formula. So then if we decide to replace this period with the frequency, remember the connection between the period and the frequency, that t is equal to 1 over f, we can have it that 2 pi will give 2 pi f, that the angular velocity will give 2 pi f, because this becomes 2 pi all over 1 over f. So, and 1 over f, when you solve, finally you arrive here that the angular velocity is equal to 2 pi times the frequency, since frequency is the reciprocal of period. Okay. Now the next is the relationship between the linear velocity and the angular velocity. The relationship, the connection between the linear and the angular velocity. So we have a formula that connects the velocity of a body on a straight line, the linear velocity, and the velocity of a body performing simple harmonic motion, the angular velocity. And we have it that the linear velocity is equal to the angular velocity times the radius. This radius can also be replaced by the amplitude. The amplitude is the maximum displacement or the maximum distance of the body from the fixed position. Okay, so we have it that V is equal to omega times R, where omega is the angular velocity and R is the radius or the amplitude, just like I said before.